All right, lesson 12.2, part 2. We're going to start here with theorem 12.2. If a line in the plane of the circle is perpendicular to the radius at the endpoint on the circle, then the line is tangent to the circle. So before we said if the line was tangent to the circle, then the line was perpendicular to the radius. So now if it's perpendicular to the radius, then we can say the line is tangent. So let's look at example 3. Is this line ML tangent to circle N at L? Explain. So if we're going to see that this is going to be tangent, then therefore it should be a right triangle, which means that this right here would be my right angle. So we're trying to check to see, is this correct? So the way we're going to do this is we're going to go back the same way we check to see if a right triangle was a right triangle by using Pythagorean theorem. So we'll take the two legs, 7 squared plus 24 squared, and we're going to set it equal to our hypotenuse, which is 25 squared. So 7 squared is 49. 24 squared is 576. And it's equal to 25 squared, which is 625. So add these two together and we get 625 is equal to 625. And because this is true, then we say that yes. Okay, is this tangent to it? So yes, ML is tangent to circle N at L. So ML is tangent to circle N at L. All right, you guys try the next one. Using the same diagram. If NL is equal to 4, ML is 7, and NM is equal to 8. Is ML tangent to circle N at L? So that means that we're going to take NL, which is going to be 4, that's one of the legs. And then we have ML, which is the other leg at 7. And our NM is our hypotenuse, so we're seeing is 4 squared plus 7 squared equal to 8 squared. So 4 squared is 16, 7 squared is 49, and we have 8 squared, which is 64. So if you add these two together, 16 and 49 is going to be 65, which is not equal to 64. So we would say that no, ML is not tangent to circle N. Okay, so now we've looked at how to find a missing length of a right triangle. We've looked at identifying if something's tangent or not by using Pythagorean theorem. Now let's look at what happens when we're asked to find the radius of a circle. Now notice we're going to have two variables because we have two radiuses in our picture. This part is a radius, so is this. So we're going to use Pythagorean theorem once again to check to find our value of x. So this leg is x, so we're going to have x squared. The other leg is from b to a, which is going to be 12 squared, equal to the hypotenuse squared. Now the hypotenuse is the distance from a to c. So the distance from here to here is 8, the distance from here to here is x, so the entire distance is going to be found by adding our two segments, x plus 8. Now, when you square all of these, x squared we know how to do, 12 squared is 144, but x plus 8 is the same thing as squared is x plus 8 times x plus 8. So we're going to use the FOIL method. So we take the first numbers, x and x is x squared, x times 8, those are two outside is 8x, the two inside, x times 8 is 8x, and the two last is 8 times 8, which is 64. So now we combine our middle terms, which gives us x squared plus 16x plus 64. And so we're going to substitute this whole in over here for the x plus 8 all squared. So now it's a matter of solving for x. So the one thing you'll notice here that the coefficient in front of the x, both x squareds, is a positive 1, which means when we subtract them, bring 1 to the other side, it's going to cancel out. So if I bring the x squared over here, it's going to leave me with 0 x squareds, which means that I'm going to have my only x's over here, so that means I need to bring the 64 to the 144. So I'm going to subtract 64. 144 minus 64 is 80. So 80 is equal to 16x. So we divide by 16, and x is equal to 80 divided by 16, which is going to be 5. So our radius is going to be 5. So remember, the distance from A to C is the distance that x plus the distance of 8. And so in order to square this, you cannot just say this is x squared plus 8 squared. You're squaring the entire expression, which means you're going to have to use the FOIL method. All right, so pause the video, try part B, and come back to see the results. So let's see how you did. We know we have x squared, one of our legs, the other leg is 10, equal to the sum, which is going to be x plus 6, all squared. X squared plus 100 is equal to x plus 6 all squared, which is going to end up being x squared plus 12x plus 36. So the x's are going to cancel. X squareds are canceling. We're going to move the 36 over. And that leaves us with 64 equal to 12x. Divide by 12, and you'll notice that 12 does not go into 64 evenly. And most of the time, they're going to want you to leave an exact answer, which means we need to simplify this fraction. So we look to see what numbers can go into both. 4 goes into 64. It also goes into 12, so it goes into 12 3 times. It goes into 64 16 times. So we get x equal to 16 thirds. So not every problem will come out to be a nice whole number. Sometimes you'll get fractions. You're going to want to try to avoid the decimals and leave it in exact form, because this would have been a repeating decimal and it would have been 5.3 repeating. So it's best to leave it in fraction form. But remember, MathXL will always give you the way they want it. All right. Next, Theorem 12.3. If two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. This is what the problem I call the cone head problem. Because if you've ever seen the movie Coneheads, their heads are shaped like a cone. In order for them to not look funny, or funnier than they are, the two sides need to be the same length. So if you have two tangent lines that meet outside a circle, they will be the same measure. So if BA and BC are tangent to circle O at their points A and C, okay, then the length of BA is congruent to BC. So therefore, these two would be the same. Now, in this figure down here, we have the sides of a triangle are tangent to the circle. So what we say is that the circle is inscribed in the triangle. So the circle is drawn inside the triangle, so that means that each point where it touches the triangle is a point of tangency. So the triangle is also going to be said as circumscribed about the circle. So it's a point of reference, which means that in this problem, in this picture, the triangle touches a circle right here, and right here, which means that this segment is the same as this length. We have three cone head problems. This one here, and this one down here. So these two are going to be the same, and this length should be the same as this length. So let's apply this to a problem. In example 5a, circles inscribed in polygons. Circle O is inscribed in triangle ABC. What is the perimeter of triangle ABC? So in order to find the perimeter, we know the perimeter is going to be found by taking the length of AB plus the length of BC plus the length of AC. Now we know the length of AB is going to be 10 plus 15. We add these two together to get 25. So we can substitute this in for 25 for AB. Now for BC, we have an unknown number here. We have an unknown side. But because this is inscribed, we know that this is the point of tangency at E and D, which means this length is also 15. So over here we have another unknown length. But we know that since these two are tangent, and if this is 8, then this length over here is 8. So now we can find the entire length of BC by adding 8 plus 15, which gives us 23. So the length of BC is 23. And that leaves us with our last side, AC. Now we know that this is 8, and because of these two lines being tangent, meeting outside the circle, that means this is also going to be 10. So we do 10 plus 8, which gives us 18. So that gives us our last segment. Now another way you could have summed up these three sides is by just taking the ones that are tangent. 10 plus 10 is 20, 15 and 15 is 30, and 8 and 8 is 16. You could add all those three up, and that would give us the perimeter. So perimeter is going to be 25 plus 23 plus 18, and that's going to give us a total of 66 centimeters. So make sure you go in, and if you have to draw the picture out, and draw in every single segment. Makes it easier to see what side you're looking for and what side you're missing. So let's take a look at the last problem. This time they give us the perimeter. They tell us that the perimeter is 88 centimeters. What is the length of Q to Y? So we're missing one of our segments. Now notice they don't give us either the segment QX or QY. We know that these two are going to be congruent together because our circle is inscribed inside of our triangle. So we're going to go back to filling in what we know. If this is PX is 15, then PZ is also 15. If ZR is 17, then RY is 17. And since these are both unknowns, I'm going to use the variable X to plug in and to describe this distance. So now I have 15 plus 15, which is going to give me 30. Then I take 17 and 17, which is going to give me 34. And then I have x plus x, which gives me 2x, which is equal to my perimeter of 88. So now I add these two together, which gives us 64 plus 2x, which is equal to 88. Subtract 64, and 2x is equal to 88 minus 64, which is going to be 24. Divide that by 2, and x is equal to 12. So our missing length right here is 12, and this one is 12 as well. So you can always go back and check it by adding all these together to make sure they do all add up to be 88. And that concludes part 2 of lesson 12.1.